Hello, I'm Edward Tarte, a math teacher. This is another in a series of solution videos for math challenge videos of mine. The particular math challenge video in this situation is my Pascal's triangle video. In that video, I introduced the special array of numbers developed by Blaise Pascal, known as Pascal's triangle, in which we have ones along both the left side and the right side, and in the interior each number is gotten by adding the number diagonally above it to the left plus the number diagonally above it to the right. For example, this 6 comes from 3 plus 3. Further down, this 15 comes from 10 plus 5, and so on. The triangle continues downward indefinitely. Alongside Pascal's triangle, I made a list of square numbers, that is, counting numbers gotten by multiplying a counting number by itself. 1 squared is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. Then in the original video, I said this: can we find a list of square numbers, these black numbers here, in Pascal's triangle? No, we can't. But there is a list of these square numbers hidden in Pascal's triangle, and that's your challenge. Find that way of getting square numbers from Pascal's triangle and explain why it works. Explain it geometrically. Here's my solution. I have written 3 more rows of Pascal's triangle. As we've said, it goes on indefinitely. The key to the solution is a list that is found in Pascal's triangle. There are 2 of these lists in Pascal's triangle. The one that I have enclosed slants diagonally downward to the left. There's one like it that you can see that slants diagonally downward to the right. These numbers, 1, 3, 6, 10, 15, and 21, and 28, 36, and so on, are known as triangular numbers. And they're gotten this way: 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and so on. They are called triangular numbers because they can be arranged in triangles. Here we have the triangular number 3 arranged, as you see, in a triangle with 1, we'll call them marbles, 1 marble on top, 2 marbles below it. I put a row of 3 marbles below that, and we have the triangular number 6. I put 4 marbles below that. We have the triangular number 10, which reminds me of the 10 pins in a bowling alley. I put 5 marbles below that, and I have the triangular number 15, and so on indefinitely. Here is the list of triangular numbers from that diagonal list in Pascal's triangle, and here is a list of square numbers down through 8 times 8. We can get this list of square numbers from the list of triangular numbers simply by adding 2 consecutive triangular numbers as we go down. We'll start with the single number 1, which is the first square number. Then 1 plus 3 is 4, 3 plus 6 is 9, 6 plus 10 is 16, 10 plus 15 is 25, 15 plus 21 is 36, 21 plus 28 is 49, and 28 plus 36 is 64, and so on indefinitely. Now, I asked in the challenge for a geometric interpretation. Here is my response. This example uses the consecutive triangular numbers 10 and 15. I put them together as shown here, forming 10 plus 15, which add up to the square number 25, 5 times 5. And indeed, we can see that the smaller triangle 10 plus the larger triangle 15 form a 5 by 5 square. Granted, it's slanted, but that's okay. It is clearly 5 by 5. Any two consecutive triangular numbers can be positioned in this way to show geometrically that they form a square number. So that is my solution to my Pascal's triangle challenge. Thank you for watching this solution video.